Welcome. Today we're going to be discussing solving systems of equations by elimination. So let's look at our notes. Steps 1, get your equations in standard form. Now this is a little different from our slope-intercept form. We have our x and y variables on one side and our constant on the other. It looks like, I'll just highlight this area here, ax plus by equals c. We will decide which variable to eliminate. We're going to line our x's up and our y's up one directly underneath each other. Then we're going to add the equations to eliminate the chosen variable and find the other variable by plugging it back into one of the original equations, and then check the answer in both of the original equations, just like we did graphically. So if we look at example 1, we see that our equations are already in standard form. They are already lined up. Our x's line up and our y's line up. So here are our x's, here are our y's, and then we have our constants at the end. Now one variable will lend itself to being eliminated more easily than the other variable, and it looks like when we add these two, our y's will drop out because I have a positive y and a negative y, and when I add those two together, I wind up with 4x equaling 12. Now that's a one-step equation. We solve for x, and we wind up with x equaling 3. Well, I'm halfway home, so I found my x, and now I want to find my y. So I have to go back into one of my original equations, and I want to find y. So I'm going to use, doesn't really matter, x plus y equals 5, taking the 3 that I found to be my value of x and plugging it into x. I wind up with 3 plus y equals 5, and y equals 2. So now I have my point. This is the solution to this system of equations. Remember when we were solving graphically, we came up with a point, and when it was substituted back into both equations, it wound up being true for both equations. So for my check, I'm going to start by going back to the original equation, plugging in the values for x and y, and seeing if both sides equal each other. That equation works, and we have 3x plus y equaling 7. 3 times 3, sorry about that, that should be a subtracting. It should be minus, let me start again. 3x minus y equals 7. 3 times 3 minus 2 equals 7. 9 minus 2 equals 7, and 7 equals 7. Check. Okay. Let's continue working, and if you have questions, just start jotting them off to the side, and we'll try to address those when you come to class. So we have example number 2, and in example number 2, both equations are in standard form, and they're both lined up. My x's are lined up with one another, my y's are lined up. But if I look at my x's and I add them together, I will wind up with 8x, and that doesn't eliminate the x. So let's look at the y's. And if I look at my y's, one is negative and one is positive, but if I add them together, they still don't eliminate because they have to not only be opposite signs, they also have to have the same coefficient. Okay, so 4 and 4 are the same, but they're not opposite sides. And my y's, I have opposite signs, but I don't have the same coefficient. So we can do, the easier of the two would probably be to multiply one of those equations through by a negative, which is what we'll do. So if I take my first equation and I multiply it through by a negative, I wind up with negative 4x minus y equals negative 7. Now it's okay to multiply through by a negative 1 as long as I do it to both sides, which is why I put the parentheses around the entire equation. Now I'm going to line up my equations in the same fashion, and technically we're adding them together, and my x's cancel now, because now they are the same coefficient as well as being opposite signs. I wind up with a negative 3y equaling a negative 9. Divide by negative 3 on both sides, and my y comes out to be 3. Okay, so now let's go back to our step 4, where we're finding the other variable, and I'm plugging this y equals 3 into one of the original equations, and let's come on over here. I didn't leave a lot of space. So 4x plus y equals 7. I found my y, so 4x plus 3 equals 7. 4x equals 4. X equals 1. Now I have my solution, 1, 3, and I need to check that. I again apologize for the amount of space. Okay, so we're going back into the original equations to check. Let's bring it down here. We have 4x plus y equals 7. 4 times 1 plus 3 equals 7. That checks. And let's check in our other equation, 4x minus 2y equals negative 2. Substituting in 4 times 1 minus 2 times 3. Does that equal negative 2? 4 minus 6 equals negative 2. Negative 2 equals negative 2, and it does check. Okay, so let's do one more together. And what happens if my equations are not in standard form? Well, that's a simple enough remedy. We can get them in standard form. He needs to be in standard form, so I'm going to bring my 5x to the other side, and it looks like that's going to work out nicely for me because it will become negative. So negative 5x plus y equals 5. Bring this equation underneath it. Let's add them together. My x's cancel. 3y plus y is 4y, and y equals 4. Found my y. Now let's find my x. Let's go back to one of the original equations. Y equals 5x plus 5. 4 equals 5x plus 5. Uh-oh. Let's try that again. Maybe I wrote it down wrong. Five x plus 3y. Let's try a different equation. 5x plus 3 times 4 equals 11. 5x plus 12, still the same thing. 5x equals negative 1. X equals negative 1 1/5. Okay, well, let's see if that checks. So I have a point, -1/5 and 4. We'll check that. 5 times -1/5. That will work out nicely because that will cancel. This winds up -1 plus 12. So that checks. And let's check my second equation. Y equals 5x plus 5. Y equals 5 times -1/5 plus 5. That shouldn't be a y, that should be 4. 4 equals -1 plus 5. 4 equals 4, and it does check. So we did have a fraction as part of our solution, but that's okay because it did wind up coming just in here and here. It wound up coming out to a whole number. So when you come in tomorrow, we'll be discussing more on how to solve these systems by elimination, and I will give you a whisk sheet that you'll have 3 questions to answer. Okay? Have a great day. Bye.